How are you, my friends? Lovely to be with you this afternoon. My name is Mr Dilly, of course, and welcome to this very, very special British Science Week Mr Dilly Meets STEM special today, and it's a joy to be with you. Let's get into part one of the show. Here we go. So the theme for British Science Week this year is change and adapt. Now, change, of course, is happening all around us all the time, from how our cities grow to how animals survive in the wild, from technology shaping the way we live, and to the way the universe itself is always evolving. And science can help us understand, I want to say all of that, but perhaps some of that at least. British Science Week have some brilliant resources. If you go to britishscienceweek.org, they've got resources for early years, resources for primary schools, and resources for secondary schools as well. If you want to download this, go to that link, look for the activity packs, and they're all free, and there's lots of different ideas for you to enjoy. So, are we ready to continue, my friends, as we go into British Science Week proper and a world of science, adventure, and imagination? Let's put our hands together and welcome to Mr. Dilly Meets the wonder that is Vashti Hardy. Hello, Vashti. How are you? And Dr. Lucía Pérez-Díaz. Hello, Dr. Lucía. How are you? How are you both? Are you well?
Really well, thank you.
Fantastic. Well, listen, it's a joy to have you on today. Thank you very much. To kick off, we thought we'd ask some three questions, not each, but the same question, and to get their thoughts going, and also get your brains sort of working and whirring to maybe think about what you think about these questions. So the first question we have up for both our guests, and I can put it onto the screen here. Now, science and storytelling both help us understand how the world changes and adapts. But if you could time travel into the future, what's one scientific or technological change you'd love to see? Cool question. So Dr. Lucía, let's go with you first. Or any thoughts?
Oh, I have to go first. So, okay, for me, being an earth scientist is possibly not going to be a surprise what my answer to this is going to be. I would love to see us having mastered some form of clean energy, because that would be such a game changer for the planet and for us in the planet to be able to get our energy from a source that didn't cause global warming and didn't cause climate change.
Great idea. I wonder if that, I'm sure it's possible, but when it will happen.
Oh,
yeah,
we are on our way there.
We're on our way.
It probably will not just be one source. It will be a few sources of clean energy. But still, I'd be really curious to see where we end up.
Yeah, absolutely. Fantastic answer. What about you, Vashti? Any thoughts about that?
Oh, mine's a tiny bit more self-serving, I'm afraid. Mine's teleportation. Because, I mean, actually, it would be eco-friendly as well, because we wouldn't have to use, fossil fuels for travel and things. So it is eco-friendly as well. But I would love to, like I do a lot of school visits and things, I'd love to just beam into schools and arrive and, I could beam over and see you, Mr. Dilly, and have a chat and things. So
I like that idea. Teleportation and clean energy. It's a very good question. These questions, by the way, teachers can write down and you can discuss these in your class afterwards and come up with your own ideas. Maybe do a poll, see which one's more popular. Okay, another question. We're going to have three questions. This is the second question coming up now. Here we go. Everything changes and adapts, even stories, of course. If you had to rewrite a famous fairy tale or adventure story with a science twist, what would you change? What would it be? What would you change? Vashti, let's go to you first. Any thoughts about
this is right up my little alley, this one. Funny you should mention that, because actually so I had a book out last year, North and the Only One, and it's a world where humanoid AI robots have kind of taken over from humans in the future, and a girl wakes up in this city and she doesn't know how she got there. She's the last human child. And it's kind of loosely inspired by Alice in Wonderland, a little bit. So she wakes up, in this strange place. There's a bit where she actually goes down a tunnel to the underground of the AI city. And that, in my mind, I was thinking of Hansel and Gretel going down at this tunnel and falling, and Rose, the character in the story, falls down into
that's
into
really
world.
So the answer is you've already done it. So there we go. Yeah. It's already there. What about you, Lucía? Any thoughts about that? Any particular story?
Well, for me, I immediately thought of The Little Mermaid, because I think if The Little Mermaid had been a marine scientist, oceans cover 70% of Earth, but we know so little about oceans because they're so vast. So I would love to rewrite The Little Mermaid and make her into a scientist that finds out all kinds of things, because she has this great access to oceans and all these friends that can help her. So I'm like already imagining them all with like a scientist lab coat on, collecting samples, you know, like doing research in the oceans.
I love that. There's got to be some children watching who want to write that story. That is really, really good. Okay, fantastic. Okay, so last one's a bit longer. But here we go, and we start with you, Dr. Lucía, for this. Here we go. So everything is constantly evolving and changing, but what's one invention, discovery, or idea from history that you think was such a brilliant change that the world couldn't do without today? That's quite big, isn't it? I know.
Well, yeah, it is quite big, and maybe I've gone really far back, because the first thing I thought was language. Because how would we do anything without language? I don't think language classes as a discovery or an invention, though, but like it's something that humans developed. So I think it would be very, very hard to do any kind of science or anything else without language having evolved.
Language, that's a great answer. And what about you, Vashti? Any thoughts about that?
No, I was actually going to say exactly the same, because I think I do think, you know, the written word, language, is a technological advancement. Sometimes we don't think of, like, you know, the first stone tools or, like, you know, the first markings that we use to communicate as technology, but they are really. So yeah, I'm thinking along the same lines, you know, like language, I think would be one thing that we couldn't live without. And then it's interesting to see how language has evolved into, you know, computer language and all the other types of communication that we have. So yeah.
Language, just on that alone, we could speak all day. I'm fascinated by that, but we cannot. So listen, thank you very much. There are three great questions for you to discuss in your class at any time. The teachers do make a note of them. That's great. Now, we are going to obviously hear more from Vashti a bit later on. We speak about her book and her thoughts, and also a part of our author panel later on. So we're going to say goodbye to Vashti now, and we're going to be with Dr. Lucía, and we're going to expand and find out all about her wonderful work. So Vashti, for now, round of applause. See you in a bit. Thank you so much. Cheers. Thank you so much. Okay, so it's just me and you now. Me and you. Right. Okay, so for those of you who don't know much about you know, who you are and what you do, tell us a little bit about that, and then we're going to talk about your latest book as well. So let me just hand over to you just to tell us a little bit about that.
Okay, well, hola everyone. So my name is Lucía, and I am an earth scientist. Specifically, what I do for my job is that I use computers to create models of what Earth looked like through geological time. I'm quite new to the world of books, actually, because the book we're going to talk about is actually my first book, and it's a result of me a few years ago realizing that children and young people really, really feel very fascinated whenever I talk about what I do for a job. And so I thought, well, what better way to tell them about it than a really cool book? And
so your book, I've got a copy here. I'm sure you've got a copy there. I don't know if it'll go weird on my
I've got a copy as well, obviously.
Yeah, here we go. So it's coming out. Here we go. How the Earth works. So it digs into all that happens beneath our feet. Right. One of the main things is, and it's probably a phrase or some words people haven't heard before, plate tectonics. Plate tectonics. Can you tell us what these are and how these are a great example of how our actual Earth adapts and changes over time? So let me hand over to you to sort of give us a kind of a simple explanation of something that's quite complicated, I guess. Here we go.
Yeah, maybe I can even use my book. Plate tectonics is the name of a theory, right? Plate tectonic theory. And it's a theory that tells us that the outer layer of Earth is broken into something called tectonic plates, which look a bit like this. Big chunks that look like puzzle pieces. And these tectonic plates are constantly moving. In fact, you're all on one right now. If you're in the UK, you're in the Eurasian plate, and we're moving with it. And you probably can't feel it moving because tectonic plates move about as fast as your fingernails grow. So it's pretty slow, but next time you cut your nails, you can think of the fact that your tectonic plate has moved as much as your nails have grown. And
that's quite disgusting as well. So
well, no, come on, it's not.
No, that is the speed of them. Literally, that's the speed.
Well, that is the average speed. Some tectonic plates are faster, some are slower.
That's it. That's incredible. Anything else you want to add to that question? So I sort of cut you off.
I was going to say that they change all the time, and that is why the face of Earth, what Earth looks like today, is not the same as what it looked like 100 million years ago, or what it will look like 100 million years from now. What I do is I reconstruct what it looked in the past. I don't look at the future. Other Earth scientists do.
Well, actually, that leads us into the next question. Actually, this is an interesting thing, and it kind of links to something you've already kind of said as well. But this is it. As your book shows us, the Earth is always changing. If you just said, if you could see our planet 1 million years in the future, what do you think it might look like? And maybe given what you've just said as well about plate tectonics.
Oh gosh, 1 million years is a long time.
Yeah.
So the Earth goes through cycles, generally speaking, in terms of plate tectonics, where all the continents kind of bunch up together. Some of you may have heard of something called Pangaea, which is the last supercontinent. So a couple 100 million years ago, all the continents that we have today were together, forming this big supercontinent. And then supercontinents break apart. And then they come back, continents come back together again and break apart. So in 1 million years' time, it could be that the Earth has different continents to what we have today. I mean, it certainly will. They could all be together. They might not be together. We'll certainly just have a very different looking planet, still partly covered in water and partly covered in continents. But the shapes and where they will be and where a specific city will be, that is really, really hard to model. The most we can model is a couple 100 million years. And even then, there's like 5 or 6 hypotheses of what the world could look like, only in a couple 100 million years.
That's absolutely incredible. So all these countries we have today will be different countries formed to different other parts of that are certain current countries at the moment, all linking up together in different ways as things evolve. So it's quite incredible.
Yeah, some time ago, say Africa and South America were together, and you could walk. Actually, I have a picture there, and you could walk from Africa to South America without crossing an ocean.
That's right. And Britain, of course, was linked to Europe, wasn't it?
Yeah.
Not that long ago.
And to North America.
And to North America. It's incredible. Okay, so we've got a school question for you. Here we go. So this is from Sporting St. Paul's Primary School, Lincolnshire. Thank you very much for your question. What do you think the most amazing thing about Earth is? That's a big question to ask an Earth scientist.
The most amazing thing about Earth is, I think the most fascinating, and maybe it's fascinating because we don't have a full answer, which is something I really love about what I do about plate tectonics and geodynamics. We have a lot of things that we don't have an answer for, is why exactly does Earth have plate tectonics? How is this rock floating in space, seemingly just a rock? How can it be so active? How can it have all these plates that are moving all the time, that are the reason we have mountains and oceans? They're the reason we have a stable climate. They may even be the reason we have life on Earth. This is something some scientists think. The plate tectonics is why life originated on Earth and not in other planets. So I think that's one of the most interesting things. It's like, if you look at our neighbors, Venus, Mars, they don't have plate tectonics. No other planet in the solar system does. No other planet that we know of does. So why does Earth have it? And that's an open question. So if you one day become scientists, maybe it's something you'll be looking at.
That's really fascinating. All these things, and you're going to find this throughout the show today. There's all sorts of baffling things, even coming up later on. You just think, I don't understand that, and it's just that it gives you that sense of wonder, and that is one of them. Okay, let's have another question, and then I know you're going to give us a quick reading as well. So let's have a little thing here. This is also a theme in your book about looking after our planet as well and the environment. So let's have this question here. So if Earth could talk, what do you think it would say to us about looking after our planet? Either how we have done it in the last, say, 60 years and how we are trying to do it maybe for the next 60 years and the future.
I think it would probably say, slow down. That's the problem with humans. We move very fast and we want things to evolve very fast. So Earth has all of the resources we could possibly need to survive and to thrive. In fact, life has been thriving on Earth for billions of years. But we are being too fast. We're consuming the resources too fast. And so Earth can't really keep up with us. In the book, I talk about how plate tectonics is able to keep the Earth's climate stable over long periods of time because it's able to control something called the carbon cycle, which I'm sure lots of you know about. But humans are adding carbon to the atmosphere so fast that regardless of plate tectonics, regardless of Earth's best efforts, it can't keep up. It can't remove all of that carbon we're adding. So I think if it could talk, it would say, please slow down, be a bit more mindful of what I can give you and the speed at which I can give it to you.
And that's something you have to ask, all of us ask ourselves, no matter what age, and what we can do to bring things a little bit slower, make them a little bit less consuming everything all the time. You're going to give us a little bit of a reading now. Let me just get rid of this question. We do have another school question, a quick course question after that. So I'll hand over to you. Give us a little bit of context, and let's have a look at your wonderful book. So here's our reading from How the Earth Works. Here we go.
So I'm just going to read you from the beginning of the book, a couple of pages. Our solar system is made up of 8 planets, hundreds of moons, and thousands of asteroids, all orbiting around one star, the Sun. Only one of these places is home to life today, our Earth. Earth is a rocky planet, and so are Mercury, Venus, and Mars. Unlike the 4 gas giants, which are cold and inhospitable planets without solid surfaces, the rocky planets are made up of, well, rocks and metals. With its magnificent mountains and deep oceans, rich rainforests and arid deserts, freshwater lakes and lush mangroves, Earth looks very different to the other rocky planets, doesn't it? Despite this, they all are the same age, about 4 billion years, 4.5. Hidden through Earth's landscapes are the clues telling us all we need to know about its life story. The detectives searching for these clues and putting them together are called Earth scientists, like me. Some decades ago, they discovered that Earth has a well-kept secret that not only explains why it's so different from its neighbors, but also might even be the reason we are all here today. And it's happening right beneath your feet. The thing about secrets is they are quite hard to figure out. It's one thing to realize Earth is quite different from its neighbors, but finding out why, that's trickier. It all starts with a pretty simple question. Has Earth always looked the way it does today? At first, people assumed that continents and oceans must be permanent features on Earth's surface and had not changed since Earth's life began. After all, how could something as big as a continent possibly move? But as explorers started traveling the world and drawing the first detailed maps of our planet, they began to suspect that things maybe were not that simple. I think I'll leave it there. I'll leave the mystery there.
That's brilliant. That's brilliant. Now you can see just some of the illustrations in the book as well. So you've got the plate tectonic theory there, and all these wonderful illustrations as you go through. You've also got yourself illustrated in there, haven't you? I haven't got the with your. Here we go. There's a version.
Yeah,
there we go. Yeah, fantastic. Throughout the book, and I've got to say, it's a really accessible, easy way to sort of find out about this and find out about our Earth, our planet, and the history of it, really, and where things are going with it. One of the things I know you're keen on, we're going to finish this with a fun question as well, is about encouraging children to be scientists and get into science, and it's something that's very close to your heart. So with that in mind, we have a final question for you here. So St. John Vianney, RC Primary School, Sutton Heath, thank you for your question. Does being a scientist always mean having wacky hair, a white coat, and working in a laboratory? So I hand over to you.
I don't know. Is my hair wacky? I mean, it's a bit wacky. I have like white hair in the front, but no, not at all, as I'm sure you can tell. So as an earth scientist, I have worked in a laboratory at one point. Lots of us don't. At the moment, I work with computers. So I sit in front of the computer. Other earth scientists work outside in the field. It's the best thing about being a scientist is that it's so varied. Science is so huge, and there are so many fields you could go into that what one scientist does versus a different one can be completely different, which I think it's pretty exciting. And also being a scientist is, to be honest, I always say to children and to young people, being a scientist is just being a professional question asker. All you do all day is ask questions and wonder about things and try to find answers. And then sometimes we find answers, and sometimes it goes a really long time until we can figure something out. Plate tectonics took many decades, in fact, probably hundreds of years to be properly figured out. And now we just read about it and it's like, oh, okay, that's easy. Well, it took a really long time to become.
Well, sometimes it just gives you more and more questions, doesn't it? I mean, you sort of touched on that earlier on. It just gives you more and more questions. Of course, if you want to have wacky hair and a white coat. Any children watching, obviously that doesn't stop you. You can go into it if you want to go for that look, the old Back to the Future Christopher Lloyd look. That's fantastic. Now, How the Earth Works, of course, is out now. Wonderful book. We'll be talking to Dr. Lucía a little bit later on, as well as part of our author panel with Vashti. But fascinating to talk to you. I'll give you a round of applause. Everyone, put their hands together. Round of applause across the UK. Thank you very much. We'll speak to you in a bit later on. Thank you very much. So see what I mean? Is all these things are like incredibly fascinating, just sort of spark all kinds of questions and debates and things you might want to talk about in your classroom, or even walking home from school, like, hey, what's that about? And go and find out all about it. Now, before we get to my next guest, as I said, the theme of British Science Week is change and adapt. And one of the things that changes and adapts all around us is plants. And selective plant breeding is a fantastic example of how humans have influenced plant adaptation, sometimes for the better, sometimes for the worse, but we certainly wouldn't have the food we have today and the accessibility to the food we have today without it. So this is a short animation from the American Seed Trade Association, about 2.5 minutes, just to talk about that. And it's another thing you can think about in your class about adaptation, a good thing, bad thing, human interference in things. Before we welcome my next guest, Vashti Hardy. So have a look at this.
You might not know this, but every day you reap the benefits of plant breeding. In fact, much of what you eat could not exist without it. Plant breeding started many thousands of years ago when people first domesticated wild plants. By selecting the best plants and breeding them over time, ancient farmers cultivated crops that were ever tastier, more nutritious, and more resilient. As scientists like Gregor Mendel began to discover how plant characteristics are passed from one generation to the next, they laid the foundation for our modern understanding of plant genetics. As the years went by, scientists' understanding of agriculture continued to progress. In the 20th century, we made incredible breakthroughs in understanding the mechanics of genetics, DNA, the genetic code, and how to read whole genomes. Each advance increased the efficiency of breeding better crops. Today, our understanding of how to harness plant breeding continues to progress, but we also face new challenges every day, like the global spread of plant diseases and pests, dwindling natural resources, climate change, and skyrocketing global population growth. Helping farmers keep pace with these challenges in a safe and sustainable way continues to be the goal of plant breeders. Thanks to our understanding of genetics, we now know how plant breeding works at the molecular level. When scientists combine genes from two related plants, their offspring have a mix of characteristics from both parents. But plant scientists have to selectively breed plants for many generations to single out one desired characteristic, a process that can take years. Now, innovative gene editing techniques allow plant scientists to use DNA from the plant's family to directly add, delete, or replace specific genetic information using its own biological processes. Just like traditional plant breeding, but with greater precision and efficiency that we've come to expect in modern times. Throughout history, consumer and farmer needs have been answered with science. What could the future hold? More sustainable food production, better tasting and more nutritious produce, increased protection of plants from drought and diseases, adapting the basic principles that have been used for generations. Today's evolving plant breeding methods are preparing us to face 21st century challenges.
Okay, some fascinating stuff there. And what does the future hold in all sorts of ways? So who knew? Well, now you do. Okay, so it's time to welcome back my next live guest today, the wonderful Vashti Hardy. Round of applause. Vashti's back. How are you? How's it all going? Are you enjoying this so far?
Oh, I'm loving it. And I'm desperate to get Lucia's book now. It sounded amazing.
Oh, it's absolutely fascinating stuff. So, Vashti, now obviously you've written many books, and many of the children watching will be familiar with all the books you have written, of course. But you've now got your latest, The Clockwork Key. Now, just to say very, very quickly, this is a very slim book by a great publisher called Barrington Stoke. And so if you are a sort of reluctant reader, or you struggle with reading, or maybe you're just dyslexic, these are great books to have a go at. They're written on in a special sort of font on a slightly sort of a cream paper to help your eyes. So they're brilliant books. But Vashti, tell us a little bit about, well, as I said, I'm sure most of the children are familiar with who you are. Tell us a bit about who you are, what you've written, and then we're going to come on to talking about the Clockwork Key as well. So here we go.
Brilliant. So yes, I'm an author of fantasy children's books, but you'll always find some sort of science or invention in the fabric of my stories, because writing fantasy worlds is a great way to explore real life scientific questions in the sort of umbrella of an adventure story. So the beauty of it when you write fantasy stories is you can make the impossible possible. You can invent anything and it will work in your story. You don't have to kind of make prototypes and things. So all my stories have a great kind of science side to it. And the reason I do that is because I loved science at school, and I loved biology, physics especially, but I thought I might be a scientist at one point, but then I signed up for A-level physics. I was the only girl in the class, and I kind of got cold feet, and I gave up on my physics A-level, and I changed to geography, actually, which I love as well. But it sneaks into your life. So kind of now I have lots of strong female characters in my books to kind of try and redress that balance a little bit.
Well, we'll talk about that. So your latest book. So let's got a quick question out. The Clockwork Key. Your character search for a lost town of clockwork inventions. What inspired this idea, and what do you love most about old mechanical technology? Because that kind of features as a theme through quite a lot of your books as well. So let's have a question.
Yeah, so in the Clockwork Key, it was really inspired by my love of kind of historic technology, because I think often we think of technology as a very present thing, but actually, like we said before about writing and the first flint tools, technology is embedded over thousands and thousands of years of human evolution. And I also love Indiana Jones, the Indiana Jones film. I always wanted to write a story that put children in the center of like a relic hunter story. So I thought, why not marry the two things that I love and have like a bit of an Indiana Jones relic hunter story alongside some technology. And in a fantasy world, you can create any history you want. So I thought, what if I create a world where they have some really interesting technological hidden sort of artifacts that have been forgotten, that two children in my story, a brother and sister pairing, Mabel and Will Greystone there, and they're very grumpy. Where is he? Grumpy cat, Relic, a stuffed cat, Grim, who's just never cracks a smile pretty much, but he's really good for the comedic value. What if they went around their world with their Aunt Lucy looking for amazing artifacts?
Which was about that. So your books, they and you sort of mentioned it already, but they're a balance between, I guess it kind of runs sort of what technology can do and what it should do in a sense. And Dr. Lucía sort of touched on that, what we should do, what we can do, what we are doing, what we all the rest of it. Let's go into the other question, which kind of links into that. So in a world where technology is advancing so fast, and Dr. Lucía was saying, obviously, slow down in what we're doing, how do we make sure we use it for good? Which is obviously, especially at the moment with the speed of things like AI and stuff like that, and the technological and scientific advances in all sorts of fields linked to that as well. Any thoughts about that at all?
Gosh, I think this is an eternal question, and something that I do explore a little bit in this book, because I think humans, the one thing we're very good at pushing technology and discovery, but we're not so good at working together. Sometimes we work with very selfish intentions, and we work as individuals, and we don't think of the wider sense of humanity as a family. And we're so worried about whether someone else might use something for bad intentions that then we end up kind of in these historic races of technology where people just want to get there first and don't necessarily think, it's like Jurassic Park, isn't it? Just because you can, it doesn't mean that you should always. Yeah. So I don't know the answer. I wish I knew the answer. I think the answer is probably in all the children out there that are watching this. They're the future of science and technology. It's in their hands to kind of do the best that they can with it. So I hold great faith in the future children.
Yeah. Well, it's that weird thing about anything, isn't it? Is that, you know, there's the freedom to do it and invent it, a bit like that Jurassic Park line, but also the responsibility of how you wield it, you know, and that's always a difficult bit, isn't it? Let's go to a school question, which kind of links to your writing and science as well. So this is from St. John Fisher Catholic College, Newcastle under Lyme. Thank you very much for your question. How easy is it to incorporate science into fiction? You sort of mentioned your influences and background and stuff. So anything you'd like to add to that?
Oh, it's super easy because, like I say, you make up the rules of your world. So you can make any invention that you like. So, for example, in one of my stories, Wild Spark, they can bring back ghosts and put them inside lifelike animal robots, because I just thought that would be such a fun, incredible idea. And what a complex world it ended up being, with lots of ethical questions. You can have like Brightstorm there in the back. You can have skyships that run on water engines. You can make all these, you know, ecological things that would help our planet be a possibility. So it's really easy to put science into fiction, because you can invent whatever you like and make the incredible make the incredible a reality.
Yeah, absolutely. And I mean, you do that so well in all your books. It's brilliant. We're going to have a little reading from you. I've got another school question after that as well. So is this from the Clockwork Key, the reading?
Yeah, this is so they go looking for this lost city of Umber, and they have a map and a strange clockwork key that they don't know what it belongs to. And Mabel's a very curious individual, and she sneaks off and finds this very peculiar invention. So I'll read you a tiny bit of when she finds it. Mabel stepped across the floor. As she neared the girl, she realized her dress was made of metal and that her face was smooth like a perfect porcelain doll. She stood by a metal throne, her expression frozen. How strange, Mabel mumbled. She walked around the statue, taking in the detail of her jewelled headdress, her perfect features, glassy eyes and metal joints. Who would make a princess doll? Then Mabel noticed something in the statue's back, a hole shaped like a crooked star. She gasped. It couldn't be. She took the clockwork key from her pocket. The pattern matched perfectly. Mabel, Grim warned. But Mabel couldn't possibly wait. She put the key in the doll's back and turned it, then scrunched her hands up and stood back. Mabel watched the doll intently, but it didn't move. Of course it didn't. It had been like this for hundreds of years and was likely broken. She put her hands on her hips and looked around the room. Perhaps there was some oil or tools she could use. Hello, said a voice. Have you seen my music box? Mabel clamped her hand to her mouth. Slowly she turned back to the doll. It had spoken. Hello, the doll said again as Mabel faced her. Then with creaking joints, the doll's arms moved stiffly to her sides. You're... Mabel searched for the right word. Awake? Alive? A clockwork doll. Princess, actually, she said. Have you seen my music box? I shall leave it there for you. But as you kind of progress in the story, you'll find out that this clockwork doll invention, there's more to her than she sees. And it's one of these inventions that maybe had good intentions at first, but has gone a little bit astray. Yeah,
but as we were just saying. Now, I've got two. If we can answer these quite quickly, I've got two questions. We've got a school question and then one just from me to you as well. So here we go. So this is from Watsy Primary School, Rotherham. Thank you very much for your question. What is the most exciting part of science or about science to you?
I love all the quantum stuff, or like the kind of string theory and kind of quantum entanglement, all that I'm so excited by all of that.
Well, you're in luck because the pre-record Professor Lisa Harvey-Smith later on is exactly a little bit about the quantum stuff and all the time bending space kind of stuff, which is quite incredible. Okay, fantastic for your question there. And this last one. So you mentioned you love championing obviously positive female role models in STEM. So this question: if you could introduce young readers to one real life scientist, inventor, or explorer from the history, who would it be? Could be female, could be male. Any thoughts about that?
Yeah, I would go for Ada Lovelace, actually, who was around early 1800s. And she was a writer and mathematician. But what she actually did, long before the first computer, early 1800s, computers were a long way off. But she actually kind of came up with the idea for a computer program that could, sorry, my granddaughter's knocking on my door, a computer program that could kind of run a computer before computers were even invented. So she was way ahead of her time. So go and look up Ada Lovelace and see.
Ada Lovelace, that's incredible. I've heard her name. I didn't know what she did. That's brilliant. Now, Vashti, I'm going to let you go and sort your granddaughter out. But we're going to speak to you a bit later on. So the Clockwork Key, one of Vashti's many books, is out now for your reading pleasure. But thank you, Vashti. We'll speak to you later on. Round of applause. Vashti Hardy, thank you very much, Vashti. So there we go. So go and sort her granddaughter. Now, in a minute, we're going to be welcoming both my guests back for our quick author panel. But I just got a little thing I want to show you. This is from it's from Quarks for Kids. Lovely YouTube videos here, and it's some fun science experiments. Now, you can do these if you can get the right bits in your classroom or at home, if you can get the right things together. And none of them are dangerous or anything else like that, but they are fun. But ask yourself as you're watching these, why do these things behave the way that they do in these experiments? And what uses do you think these experiments could have in things in our everyday lives? And so the forces at play in them, are they used in some way in our everyday lives? What do you think? Okay, let's have a look at this from Quarks for Kids, and then we're back with Dr. Lucía and Vashti again for a few more questions before we get into part 2 of the show today. Here we go. Look at that, fascinating, isn't it? So all sorts of questions there. You can discuss how they all work in your class and what uses they're used for in different things in our world today. Have a think about it. Okay, so it's time to welcome back my 2 live guests today before we get into part 2 of the show for our British Science Week author chat. Okay, so here we are all together again. Fantastic. Okay, so it's been brilliant to speak to you a bit more about your books. We got some sort of more general questions, a bit like how we sort of started with today, to think about, and you give your answers. And obviously, the children watching can also then maybe discuss these in their class as well. So let's have our first one coming up here. So here it is. Science is full of incredible discoveries. What's one scientific fact, here we go, that totally blew your mind when you first learned? It should be said learned, not quite learned it. So Vashti, any scientific fact that totally blew your mind when you first learned it or heard about it?
Yeah, I mean, I'm quite a fan of like the ancient Egyptian kind of time. And I was reading like one thing, I mean, this is a bit gross, but apparently they knew the anatomy of the human body really well. And they were able to remove the organs of the body, like the heart and the liver, and the intestine after someone had died without needing to like completely open up the body. So it's a bit of a gross fact, but I'm like, this is fascinating considering, you know, ancient Egypt goes back to, you know, 4,300 BCE onwards. And they actually had a god of science called Thoth, I think.
Yeah.
How cool is that?
Yes, and knowledge. Yes, right. They did. Yeah, which is incredible. That's great. What about you, Dr. Lucía? Any sort of thing?
Well, I have a few because last year I wrote the Earth chapter for a different book, which is called the Big Book of Useless Knowledge, but it's not useless at all. And I had to write 30 facts, like mind-blowing facts. So I'll tell you one that really stuck with me, which is that there is enough. So the inner core of Earth is a solid ball of metal. There is enough gold in there to wrap the entire planet in gold.
What?
Yeah.
Oh my
Not
goodness.
that you could get it.
You shouldn't have let that one out. You're going to have people digging all over the place.
Yeah, well, I think that'd be a little difficult because that's like 6,000 kilometers to the center of the Earth, and the deepest we've ever gone is 12 kilometers. So
yeah, it's going to be a bit tricky.
It's going to be a bit tricky.
But that is an incredible fact. Incredible fact. Look at this. It's learning stuff all the time. Okay, here we go. So here we go. Imagine you're designing a futuristic city. How would it change and adapt to be the best place to live in the future? So, Dr. Lucía, let's go with you with that. Here we go.
Oh, I mean, there's a lot of things that you change from now. I think maybe one nice thing to do, and I don't know how exactly we would do it, but would be to make cities more changeable so that at least they could adapt to things like the seasons. So maybe our buildings could adapt in some way so that in the summer they kept us cool and, you know, it was nice to be in them, and then in the winter they actually kept the warmth, and they were like a little bit changeable as well. It would be cool to have a house that depending on the season looks a bit different and changes itself.
Yeah, well, that's a good idea, because where I live, it's a house that's got no insulation or nothing. And so basically it's freezing in the winter and boiling in the summer, and there's no in between. It's just the way it kind of works. Yeah. Okay, what about you, Vashti? Any thoughts about that? Would you like to add to what Dr.
I met an incredible author in February called Steve Mushin, and he's written this book called Ultra Wild, which is all about rewilding like urban spaces, cities on Earth, all based on how, you know, all the different creatures that we used to have, and you know, how that kind of contributed to the ecosystem. So he's got some really bonkers inventions in here that you could like come up with to rewild cities. So I love this type of thing. Is right up my alley. But I think these really I love that idea of cities where we're working much more with nature. So if you're interested in this, find this book. It's amazing.
That's a great book. I haven't seen that book. That rewilding idea is great. Okay, here we go. So let's go. We can't ask all these questions. We're going to just maybe do one to two more. Here we go, because they're all kind of really interesting one. Okay, here we go. Aliens land on Earth tomorrow and ask you one question about humans. What do you think they'd ask, and how would you answer? That's a big one, isn't it? So Dr. Lucía, what I mean, they'd probably land, obviously, look, maybe they've been studying us for a long time, or maybe they just landed and got out and gone, You know, what do you think? Any thoughts?
Well, I'll tell you something like that. I think it's quite interesting. There's a theory that some people have that aliens are actually just humans from the future. So if that were true, because, you know, humans in the future, they've developed the ability to time travel, and therefore they're coming back to check on us, in which case they wouldn't ask us very much, because they probably would already know if they're just humans, but further down the line. But I think they probably would tell us, like, what are you doing? You know, what are you doing with the planet? We had to move to a different place because you ruined it. But I find that quite interesting, that to think that maybe they wouldn't ask us very much. They would come back actually to give us advice more than ask us questions.
And I think that'd be advice, and it'd be nice if we actually followed it as well, wouldn't it? Which some would, and
sure
many probably wouldn't.
We would have more questions for them than the other way around.
Yeah, absolutely. Okay, Vashti, any thoughts about that? That's a really good question. I like that.
Yeah, that's so thought-provoking, isn't it? I think one of the things they might think is, like, why are there not as many girls working in the STEM subjects as the boys?
That'll do.
You know, we've got like brilliant Dr. Lucía here, so there's a lot of girls. I think it's still only like somewhere like 22 point something % of the workforce in the UK is female in comparison to men. But I'd say to the aliens that, you know, the future's bright. I'm sure there's lots of girls out there, but now it doesn't feel such a barrier to them going into the science subjects.
Absolutely. Brilliant answer. Okay, here we go. So one last question for this little panel chat. So we've talked a lot about change, but if you could keep one thing exactly the same forever, it doesn't matter how sentimental it is, it could be something very close to you, in fact, what would it be? So Dr. Lucía, anything at all?
I think something that I value more and more as time goes by is like time spent with people. And sort of like sometimes I think we compared to like my parents, my grandparents, they spent a lot more time around people. Now we quite easily get distracted by all of our technology, don't we? And so that's something I think I'd like to change. I obviously work with computers. I'm also a digital illustrator. So when I'm working on books, I'm working on the computer. So I'm like, I try very hard to have things that don't require a computer or phone, or like, you know, and I can just go back to the people and spending time like talking to people. You learn a lot, you have a really nice time. That's something I'd like not to change.
I like that. And also I think the thing is that, and maybe the children watching don't realize this yet, or maybe they do, or maybe you realize when you get older, but because so much because of technology and how that's changed, we spend a lot of time doing what we're doing now, talking through screens, but it's very different from being on a screen with someone to meeting them in person, isn't it? It's a completely different thing, and how you experience each other in relationships. So I would agree with that. More time with people. What about you, Vashti? Any thoughts about that?
I wouldn't change books, because books, actually, if you think about it, books are time travel machines in a way. You know, someone might have written it, you know, 300-400 years ago, and you're having a dialogue with them kind of in the future. And I love that. So books are more kind of scientific than maybe we'd think of at first glance. So, I mean, I do love an audiobook, but also like a real paper book. There's something, you know, my children used to love to smell them. I have a good sniff of a book, but I love a physical book. Is a magic. There
was a great thing I saw about it, but just to add that, I don't know who said it, and I don't know if it's going to make sense to anyone watching, but it basically said, there are, you know, there are films that are made that maybe that aren't so good, or we shouldn't watch, but they're not banned. There are audiobooks that are made, they're not banned. There are, you know, music that's made. That's not, it said, but books and sort of are by their very nature sort of a rebellious thing. They're kind of something that kind of like, you know, he said, so reading is rebellion, he said, because the ideas in books are throughout history, you know. So I just thought it was such a wonderful thing, like reading is rebellion. That was a great kind of idea.
Yeah, absolutely.
It's a brilliant thing. So books as well. Now, we're going to finish our little author panel, and then you'll be there just afterwards, and we're going to say goodbye. So. Okay, so obviously loads of questions there. We could have spoke all day, but we can't do that. So Vashti Hardy, her wonderful book, The Clockwork Key, is out now. Dr. Lucía Pérez-Díaz, How the Earth Works, is out now for your reading, viewing, and puzzling, inquiring pleasure. Is there any last words you'd like to leave the children watching with today before I get into part 2 and we say goodbye to both of you? Dr. Lucía, any last words about science or encouragement?
Well, what I always say to children whenever I talk to them in schools or whenever, you know, I talk to them about the book is that be curious. And if you have questions and the questions don't have answers and the people around you can't give you the answers, don't let that discourage you. Maybe the answers you'll find later on in your life. But also about the book specifically, feel free to get in touch. I'm easy to find because I don't have a very common name, at least not in the UK. Not many people are called Dr. Lucía Pérez-Díaz. So send me a message. I love getting questions from children that have read the book and are curious.
That's a good invitation. Brilliant stuff. Thank you. And Vashti, what about yourself?
I say remember that your imagination is your superpower. And you kind of grow it through reading books, whether that's, you know, nonfiction or fantasy or whatever you're into. That's how you kind of grow this super muscle that we have, our imagination, and that's how you will, you know, change the future and kind of you know, make your stamp in life, whatever that may be. Kind of dream big.
Thank you so much. It's been a joy to have you both on today as well. But for now, we're going to say goodbye to the live guests on the show. Round of applause. Vashti Hardy, thank you very much. And Dr. Lucía Pérez-Díaz, round of applause. Thank you so much. Give us a big, big wave. Thank you very much, both of you. Thanks, Vashti. Thank you. Bye-bye. And Dr. Lucía, thank you very much. Bye-bye. So weren't they wonderful there? We're going to go into part 2. Okay, so we're going to go into our draw along now. So this is a part of, and we're going to speak to the author of this book in a moment, which is Professor Lisa Harvey-Smith. This is the illustrator of Quarks, Sparks, and Quantum Mysteries. So I'm sure Vashti would like this one about the quantum mysteries a bit later on. So we're speaking to Professor Lisa Harvey-Smith later on. This is the illustrator, and he'll be drawing something. It doesn't sound much fun, but the way he's drawn it is very, very good. It's called a lepton. I know, what's a lepton? But it's one of the building blocks of life and matter. But as you see, it's a fun draw along. So get your pens, papers ready. I'm going to hand over to Aidan now.
Thanks, Mr. Dilly. Hey, everyone. My name is Aidan, and I'm an illustrator and graphic designer based in Melbourne, Australia. And today we're going to be drawing from Lisa's book called Quarks, Sparks, and Quantum Mysteries. So some of my favorite characters that I got to draw in this book were a handful of leptons. So they were the electrons, the muons, and the tau. They're super easy and fun to draw. You know, they work as a great sort of warm-up activity for sketching. So we're going to jump into my drawing program on my computer, and then I'll show you how it's done. So the leptons are really easy and fun to draw, and they can come in any sort of shape or size that you would like, as well as different expressions, eyes, you know, anything you like. It's built up of a lot of fun, different shapes. So first off, we're just going to draw a big circle on our page. So you can draw with a pencil or a pen, whatever sort of is your preference. I normally like to just get straight into it and draw with the pen. You know, working on a digital computer, I can clean up my mistakes, but you know, if you make mistakes, it's totally fine. You can always just redraw it again. It's all quite simple. So I've got my main lepton shape. I'm not sure what it's going to be yet. It could be electron, a muon, or a tau. We'll see what happens when I start drawing. So I'm going to draw the face first. I'm going to draw some eyes. I'm going to draw them rather large. Eye number 1. And then I'm going to draw a little nose. Once again, just little circles, and then another eye. Looks pretty good. And then we can add in the pupils of the eyes. So I'm going to make these nice and big and color those in. Once again, it's up to you what size you would like to make these. You can have as much fun with them as you can. Looks pretty cute. I'm into that. And then I will add in just a little bit of detail to the cheeks and add in some happy little eyebrows. Next, I can draw the mouth. I might draw this one quite big, because this lepton is very excited to be here. And then draw in some teeth. So I'm going to draw in some nice gap teeth there. Going to color in the mouth. Looks pretty good. And then I'm going to give it some big happy cheeks. There we go. Pretty happy with that. And now we can draw in some arms. So this guy is going to be waving at me. So draw in the thumb, like so, and you can draw in the fingers. So it's up to you how many fingers you like to draw. I normally like to keep it simple and just draw 4 fingers. You can draw 5, 6, 3, as many fingers as you would like. Looks pretty good. And then I'm just going to draw my other arm as well, just down to the side. Once again, draw the thumb, And then draw the other 3 fingers. And then just close off that arm. Looks pretty great. And then we're going to draw some feet. I might draw like he's sort of dancing a little bit, sparking up. It's pretty good. You know, you can draw your legs however which way you want to draw that. You can be straight on. I've given them so he's a little bit of a jiggle, a bit of a dance. And then what I did, so we could tell the difference between each lepton is I like to draw a little hat on top of all of them and then a little icon of their sort of science. I don't even know what it's called. So to tell the difference between each lepton, I like to draw a little hat on top with their little Greek letter so you can tell which one that they are. So if I draw a little hat, draw the brim in the middle, and then I'll draw the little hat on top. It's just like an M shape. Draw a little circle there. It's pretty good. I might even bring out that cap a little bit more and just color that in. So you can use colors in this as well if you would like. I'm just keeping mine pretty simple today, just black and white. And then I'll draw the little Greek letter. And that one is the muon. And then you can just finish off, you know, add some little shadows, give it a little bit more dimension and depth to the graphic. I like to add little shadows here, just to show that the legs and arms are behind the circle. And that looks pretty good. And then you can draw in little highlighted bits, you know, give it a bit more definition, a little bit of a shine. Cool. And then you can maybe add in a shadow down the bottom. And you can just color that in. And there we go. And then you can add in some expressive lines, like to give a little bit of movement to everything. It's very happy to be here. It's looking happy. Cool. And there we go. And that's how you draw a lepton. That's it from me. Feel free to check out the rest of my work on my website, which is heyaidan.com. And yeah, hope you guys enjoy the rest of your session. Back to you, Mr. Dilly.
Okay, fantastic. Aidan Ryan there with a little draw along from Quarks, Sparks and Quantum Mysteries. So here it is, Lisa Harvey-Smith. Here we go. Science Week special that we're running today. She is an astrophysicist, science communicator, and author of 7 books for children and adults. And she's here with the latest to talk about a wonderful book, Quarks, Sparks, I don't know what that means either, and Quantum Mysteries. Please welcome to Mr. Dilly Meets. Put your hands together. Round of applause. It's Lisa Harvey-Smith. Welcome, Lisa. How are you?
Hey, Mr. Dilly. Good to see you. Hi, everyone. Nice to see you.
Lovely to be here. So listen, the first bit is really to ask about, obviously, the title of your book and Quarks, Sparks and Quantum Mysteries. First of all, what is a quark? And then what is quantum? I don't know. What is quantum physics, I guess? So I'll hand over to you the answer to that. What's a quark, first of all?
Yeah, this is cool stuff, right? Okay, who's heard of an atom? I think most of you probably heard of atoms. And they're the tiny building blocks that make up everything. And actually, about 100 years ago or more, we found out that there's stuff inside of atoms as well. So even the tiniest building blocks are made of other things. And inside those things called particles are other particles. So really, quantum physics is about the science of the very teeny tiny, the world you can't even see with a microscope. It's so small. So we have to investigate that to understand how to build cool things like computers and lights and airplanes and cool stuff that we use in our modern world. So a quark is the tiniest particle we've ever discovered so far. And 3 of those quarks make up a proton or a neutron in our atoms that make up our bodies and make up everything in the whole universe.
That being the case, can you just keep going eventually just smaller and smaller and smaller? I mean, it's like nothing. There is no such thing as nothing. Is that correct, or am I wrong there?
So we don't know exactly. What we do is we do experiments and we fire tiny particles like protons and electrons at really, really fast speeds in particle accelerators, and we smash them against stuff and they pow off. Imagine like you're doing it on a pool or snooker table and you're hitting the white and you're smashing all the balls in different directions. So that's the kind of experiment we do as scientists to find out what's happening inside atoms. And when you do that, you figure out that you've got these tiny particles made of tinier particles. And when you get down to quarks, we can't find anything else. We don't know if they're made of other smaller things. But you know what? We'll have fun finding out and smashing them.
Is that just because of the limit of technology at the moment in order to sort of, you know, go even smaller down from that? Is it? Do you think that there will be a time when you'll be able to go smaller and then smaller and smaller in terms of that?
Yeah, well, scientists are using these cool things called particle accelerators, and they use a huge magnet to accelerate. That means get faster and faster, tiny particles that go round and round and round in a big ring, and then they hit other things and then see what's happening. Scientists are using this all the time to find cooler and smaller and more exciting and things like the Higgs boson, particles we haven't discovered yet. And I think we'll just keep discovering and discovering until we finally figure out what kind of jigsaw puzzle makes up our universe. And that's really exciting.
So your book, Quarks, Sparks, and Quantum Mysteries, you kind of explain them what they mean in the title. Tell us a little bit about the book. So if I hand over to you, tell us a little bit about the book, and then we're going to sort of go for a few questions that sort of jump around some of the themes in your book as well. And Lisa's going to give us a bit of reading as well later on. So I hand over to you. Tell us a little bit more about the actual book itself.
Yeah, we can see the book here. You can see it in my background as well. But it's really all about atoms and what's inside them and the tiny particles I've talked about already. And then the things in space that you might not know about. So things like black holes you probably heard of, but a little bit deeper into those things. And then some of the cool things in space that we don't know whether it exists yet, like wormholes, white holes, and gravitational waves, which we do know exist. And also we look into the nature of time. So what is time? And is it always the same across the universe? Can time go backwards? Can time bend? Can you time travel? And we answer all these questions that we use science to try and find out. So really Quarks, Sparks, and Quantum Mysteries is about the tiny particles, quarks, what's inside atoms, what makes up the universe, where does it all come from, how it all works, and how that relates to our amazing and fabulous universe as well.
That's amazing. And just very, very quickly, I'm sure that the children, when you mentioned time travel, they'll be fascinated by that. Is that a thing? Because obviously time does sort of shift and change, I guess, in the universe. Is that a potential thing, do you think? Or was that just literally science fiction?
It's interesting, right? Time, we think of it as tick-tock, right? You look at your watch or you look at a clock and time's going forward for us. It seems like it goes slower, doesn't it, when you're, I don't know, in a boring lesson or something at school or watching something rubbish on TV. But you know what? Time seems to us humans as pretty regular. But actually, scientifically speaking, time bends and varies and changes depending where you are. So if you're next to a huge, massive, fat object like a star, for example, or a black hole or a galaxy in space, time actually bends. And we know this because Einstein figured it out a long time ago. Now, time bending is a real effect. And actually, if you go out into space and you accelerate around the Earth, time actually travels more slowly for you. So we've actually put atomic clocks into space and you can see that time is ticking more slowly. So time can bend, it can warp, and it can be seen in different ways by different observers. So if you're flying through space, you can actually experience it differently. So we don't know if you can time travel, like go back to last week and buy that lottery ticket or whatever, but we actually do know time can change. So maybe we could manipulate time in the future and actually create time travel. But where are all these time travelers? That's my question.
Yeah. Do you know, that is absolutely incredible. That is absolutely fascinating, isn't it? That is absolutely unbelievable.
It's super cool.
I think the thing is it's that kind of, but the children watching as well. I mean, even we had a video before about cells and what's going on in our bodies and how they adapt and change. And obviously you don't know that's going on, but all this stuff is going on around us, and we obviously can't even see it, you know. But it's all happening around us. On the basis of what you said about sort of shrinking down, there's a question for you here. So, if you, it's quite a fun question, could shrink down to the size of a tiny particle for a day, maybe a quark, maybe an atom, who knows? What do you think you'd see or experience? So I'll hand over to you for that.
Brilliant.
Tell us a little bit about that. Here we go.
I love that question. So cool. I actually talk about this in the book, actually. Imagine you had an incredible shrinking machine, right? And you jumped in and you go, and you set it up and you shrink down by 1 trillion times. What would it be like? And you actually go into an atom and you become one of these particles. Inside an atom, there's a few different particles, right? There's a proton and a neutron in the middle. and then there's a bunch of electrons, and electrons are the particles that create electricity. That's why they have a similar name. So if you were one of these, let's say you're in the middle of an atom and you're one of these protons, you'd actually be made up of 3 quarks, right? So these protons are made up of 3 quarks. And imagine you shrunk then down to one of the quarks. So you're right in the middle of an atom. There's 3 quarks, so you're one of them. You've got 2 buddies, and you're exchanging bosons, these particles that glue you together, and they're called gluons. So these gluons are like firing out of each of the quarks. They're pinging off, and you're kind of jostling around, and you're sticking with your quark friends. And then you're making up the middle of the atom. Now, around you, there's some other quarks, and they're all flying off like different bosons, ping, 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 to actually create a bond between those particles and stick together. So these bosons, these gluons are gluing you together. You're jostling around, you're firing off particles, and then around you, you can see this huge, amazing thing. The size of a football stadium around you, imagine like Wembley Stadium or something. You look around and there's all these electrons, these other particles whizzing around in like a field in all directions, like a drone show or something like that. So if you could sort of play inside of an atom for a day, that's the kind of thing you'd be looking at.
God, that is absolutely fascinating. Absolutely fascinating. We got a question for you from a school, actually. Thank you for this. Or Clinic Primary School in Scotland. Did you yourself learn lots of new things about science when you were researching this book? Because obviously you're saying discoveries are happening kind of, all the time, or different angles, or different ideas and stuff. Was there anything that kind of surprised you and you think, I didn't know that taken? Any thoughts on that?
Yeah, definitely. No, I've been a scientist for 20 years, but you're always learning new stuff. So you think, I know quantum physics because I learned it when I was at university or something. But actually, by the time you've even blinked, science has changed, right? We've discovered new things. So I was actually interested in learning about the Higgs boson. You might have heard of this in the news or something, but you might not, because it's a bit specific. Anyway, what the Higgs boson is the type of particle that actually gives things mass. It makes things heavy. And without it, if there wasn't the Higgs boson, or the Higgs field it's called, in the universe, nothing would have mass at all. Can you imagine the world without that? And it's sort of, we think about things like gravity creating mass and pulling things to the earth, but really we know throughout the universe, there's different ways to describe gravity. And one of them is this Higgs field. And, discovering that by smashing particles together, again, in the way that I described earlier, in a big particle accelerator, bang, you create these Higgs bosons. That tells us that throughout the whole universe, there's this amazing invisible force field that when particles move through it, it gives them mass, that is weight, almost similar type of concept. So it makes them heavy. And if it wasn't there, we'd all just fly apart. Really cool.
I think it would be the same for a lot of the children watching and the teachers listening as well, listening to you. It's something that it's the fascination is incredible, and the way you talk about it is so interesting. You can see your enthusiasm, for it, and your love of it. So we could obviously speak about this all day. I do have a few more questions though, so we're okay. Cool. So we mentioned already the theme of British Science Week this week is change and adapt. So let's go to that. Change and adaptation. You kind of already touched on it in terms of quarks a little bit, and atoms and space bending and time bending, all the rest of it. But what other ways can I mean, this is probably a limitless question with space, obviously, isn't it? But any other ways that it can happen in space that kind of maybe touch upon or expand upon, literally, probably what you've already spoken about there. So I hand over to you for that.
Yeah, thanks. Look, I love how biology interacts with science, like other sciences. So like physical science, the study of our universe, right? So I want you all to have a look at your hand or your wrist here. And you can see maybe that you've got some blood vessels here, right? So if you can see some blood vessels on your body, what that tells you is there's blood moving through your body there. Okay. And what really fascinates me is how that blood got there. Not when you were born and throughout your life, but even before that. In fact, billions of years before that. So I just love the way the universe has changed throughout time to get to today, to this point where there are blood vessels with blood moving through your veins. So how that works, in the Big Bang, 13.8 billion years ago, the universe started to expand. It was really hot, and a load of these particles were sort of created or generated out of the Big Bang. The very first atoms started to form, and they gathered together by gravity, pulled together to make the first stars. And in the first stars, they started burning, and the atoms changed into heavier atoms and heavier atoms and heavier atoms. And then the star died, and those atoms all spilled into space and created the new generation of stars. And we're probably in the second or third generation of stars at the moment. So in the Big Bang, there was just hydrogen, which is a really light gas, even lighter than helium. There was no carbon, there was no oxygen, there was no nitrogen, there was no iron. And iron is the stuff that makes your blood red. So all that iron was actually created inside a star and was spilled into space, created, gathered up by gravity, and created new stars like our sun and our planet. And that is where all the iron in your blood came from, and that is why you have blood running through your veins and why you exist, why you are here. And I just love that adaptation of the particles in our universe is kind of almost done like magically by stars. And then that creates life, and life adapts to its environments as well. And I love the way that sort of physical science, that biological science sort of joins together.
So that line, which I've read before, is, we are made of stardust, is actually, I mean, it sounds really romantic, but it is actually true in lots of ways.
It is absolutely true. You're made of stars and the Big Bang, which is, I think, amazing.
That is amazing. That is amazing. Okay, so here we go. There's one more question, and I know you're going to give us a little reading as well. So, and here we go. So, what's an example of a big scientific discovery, maybe that's in your book, that totally changed how we see the universe? Anything else you can add to that?
My goodness. I love the fact that space and time are curved, and we talked about that earlier. That was absolutely massive. So Einstein changed the way we look at the universe, that time can actually bend. But another great discovery that happened was that in fact that the universe is expanding, and that really is quite incredible. For the longest time, for thousands of years, people thought the universe was just in a steady state. It was just sitting there going, okay, the star over here, galaxy over here, planets here, and the Earth. And, people thought of it like that. Maybe the things were moving around in circles. But actually, when we discovered in the 1930s that the universe was expanding and getting bigger and bigger, and in fact, that's accelerating, so we're getting faster and faster, that's when we discovered that in the past, it was all in one place, and that was the Big Bang. So I think that really completely overturned this wisdom that the universe was just sitting there like, static.
Dynamic. But what's that expanding into, though? I mean, what is that? That's always the weird...
That's the classic question, isn't it?
Yeah.
And it's really hard to answer that question.
Yeah.
But it's not expanding into anything. It itself is expanding. So what is expanding is the space between things, the gap between things. You've got two stars, they're getting further apart, but there isn't kind of this big space and then the universe is like inside it and it's expanding.
Yeah.
It's what we describe it as the gap between things, the space between things is getting larger. And you know what? The only way that makes sense is through maths. So it's really weird. You can't actually imagine it because your brain goes, "Ooh."
It does straight away. I mean, straight away.
It's not a very good answer, but it's maths.
Honestly,
so it's not really expanding into anything.
It's just,
the gaps are getting
incredibly complicated.
It's weird.
It is. You're going to give us a little reading now. So I'll tell you what, I'll get with this question over there. I'll hand over to you. Tell us a little bit of context about where the reading comes from. And so Lisa's going to give us a little taster of quarks, sparks, and quantum mysteries. Here we go, Lisa.
Thank you very much. Look, I want to read you a little bit about cosmic rays because this sort of illustrates how fragile we are and how things from space can actually affect us. And really how, as humans, as biological animals on this earth, we've adapted to our environment to stay safe. And that's a common theme. That's how animals have created, all the different species. We all adapt to get better at surviving. So this is all about cosmic rays. Okay. So cosmic rays are tiny, high-energy particles that fly to Earth from outer space. They move at very close to the speed of light. That's around 300 300,000 kilometers per second, and that's the fastest possible speed. Now, most cosmic rays are made up of a single proton, so that is a tiny particle that's inside of an atom. Now, a very small fraction are electrons or other particles. Now, the Earth's atmosphere and the Earth's magnetic field protect us from most cosmic rays, which is very lucky, because if cosmic rays pass through your body, they can knock an electron, another particle, off your atoms, causing damage to your cells and changing your genetic material. That's your DNA. So that's a very, very bad, because it can cause diseases and injure your heart, blood vessels, and brain. So it's just as well we have this protective shield around the Earth. Otherwise, this planet would not be such an inviting place to us. Now, back to the cosmic rays. As they hurtle through our atmospheres, they blast into molecules that make up the air we breathe, and they create exotic particles like muons, neutrons, and neutrinos, which protect us from the damage that cosmic rays would do to our bodies. This is called a cosmic ray air shower. Imagine if we could see it. I've got a little picture of the air shower right there. So it just goes to show, doesn't it, that, you know, there's nasties out there in space, and there may be things that can adapt. We know, actually, if you put bacteria on the outside of the International Space Station, it can survive these cosmic rays because it's adapted to those extreme environments. But our biological cells can't deal with it. So thinking about if we want to go and live on Mars, yikes, it's not a very good idea.
Yeah, I'm
because
okay for that, I think.
Cosmic rays would not
I
deal.
know, that's
would
horrendous.
not deal with that.
That actually leads us nicely into the next question. Actually, one of the biggest questions in science is: are we alone in the universe? How do scientists search for signs of life beyond Earth, and what kinds of clues might they look for?
Okay, well, there's two really good ways I can think of right now. I'm a radio astronomer, so I use big radio telescopes, big dishes, to look at the stars and galaxies. And one way is to use a radio telescope to look at nearby planets around other stars. And what you do is you listen out to see if you hear any radio signals. And those could be, imagine, you know, we use radio transmitters to transmit TV signals, mobile phone signals, and communications around our planet. If we lived on another planet and we were pointing our radio telescope towards Earth, we would hear the transmissions. We'd be able to watch the BBC News or Home and Away or whatever it was. So aliens might actually be watching our TV. So if we do that, we look at nearby stars and planets, we might be able to see radio transmissions from intelligent life. And the second way is we can use an optical telescope. That's a normal telescope that you'd look through, like that one, and you look at a planet and you wait until it goes in front of a star, and then you look at the light going through the edge of the planet and see if it's going through an atmosphere. And if the planet has an atmosphere, you can actually use clever science to measure what's in the atmosphere. And if it has biological signals, different molecules or atoms that suggest there could be life on that planet, then there's another clue. So really interesting different bits of science that you can do.
Wow, that's amazing.
To try and find aliens. It's not about looking for UFOs. That's not what we're doing.
Oh, that's absolutely fascinating. That's absolutely fascinating. Now, Lisa, you know, we loads we can talk to you about, of course, as I said earlier, but we have to wrap up now. But I've got to. This shouldn't be hard, but it's wonderful hearing about what you do, and you can, as I said earlier, you can clearly see your sort of passion and excitement for what you're talking about. So with that in mind, a final sort of thought, piece of encouragement for the children watching that are exploring the world through science and thinking about science more on this British Science Week. Any final sort of words of encouragement or something to think about for them?
Yeah, I would just say, look, I've been a scientist for 20 years. I'm a professor at a university and I love what I do. I love writing books. I love sharing science. And I started as a 12-year-old in Essex looking up the stars with my dad. So that's where I started. And now I've lived across the world, had an exciting career. I live in Australia now, on the other side of the planet. And I look at the moon upside down. It really is upside down in Australia. Whatever you love, it doesn't have to be astronomy, but whatever you're interested in, just go out and do it. Have a go. I looked at the stars. I joined my local astronomy group. And it might be for you bird watching, it might be studying the oceans or the rivers or animals. It might be something that takes you to a new level of interest, to find a new tribe, to find the people that you really gel with, right? And it might be outside of school, it might be in school, who knows? But really explore the world, because, just sitting on your smartphone, you're not going to discover the world. Get out there and get out and enjoy nature. So that's what I'd encourage young people to do.
That is brilliant advice to finish with. So Quarks, Sparks and Quantum Mysteries is out. It's out now. It's out now, isn't it? It's out now.
It's ready to pre-order. It's online. You can pre-order it and they'll send it out to you. You
can pre-order it now online. So brilliant. Listen, Lisa, thank you so much for coming on all the way from Australia as well. I'm going to give you a big round of applause myself. Everybody in the classrooms, come on, big round of applause. Lisa can't see you, she can't hear you, but you can get the vibe going. So
I feel good. Thank you.
So Lisa, lovely to meet you. Thank you so much, and for being on. Give us a big wave. Thanks so much.
Thanks all. Godspeed.
Go, Lisa Harvey-Smith. Long one, but I mean, it's incredible, isn't it? Blows your mind. Listen, it's been wonderful. I want to say a big thank you to Vashti Hardy today. A big thank you to Dr. Lucía Pérez-Díaz. Big thank you for Aidan, and of course to Lisa as well. And most of all, for you all for watching, and for your teachers for tuning in today for British Science Week special. Remember, keep asking questions, keep exploring, and most importantly, of course, stay curious. My name is Mr Dilly, and thanks for watching again. And it's goodbye from me. And it's goodbye from me. Goodbye, my friends. Thank you. Goodbye.